Right, so in this, we're going to be building some mathematical models or functions in some word problems. Okay, so let's start with an example. It says, let P be the point xy on the graph y equals x squared minus 1. It says, part A, express the distance from the distance d from the point to the origin of the as a function of x. Okay, so the first thing I want to do is go ahead and graph this on the calculator and kind of look at what this may look like. All right, so you will need some graphing paper here. Okay, when we graph this function, we've been practicing graphing these functions. Notice that it is a parabola that shifted down 1 unit. Okay, so when I draw this, it's simply going to be a parabola that we shift down. So remember that the parabola originally starts at the origin, but in this case, we're shifting it down 1 unit. So down 1, we have these points here. Okay, and what this question's asking for is for us to find the distance from any point on the graph to the line, to the center of the grid. So we're trying to find the point anywhere on this line to the center. Okay, and we want to do that by finding some equation that we can relate it to. Okay, so this is going to require a little bit of work, but hopefully at the end of it, it makes a little bit more sense. Okay, so it says express the distance from P to the origin as a function of as a function of x. So what we're going to be looking for here is a function d of x. Okay, this is what our goal is. One thing that you do need to recall, okay, and I'm actually going to do this on a separate piece of paper. One thing I want you to recall is that the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, now in order for this to be a function, remember that this has to include only one type of variable. In this case, it needs to include the x variable. So we need to figure out some way of getting rid of those y's. Okay, and one way that we can do this is by noticing that up here we know what our y is equal to. Okay, our y is equal to x squared minus 1. So we can actually replace our y's with x values. Okay, the other thing that we need to notice or to recognize is that all of these are going to be the distance from the origin. Okay, so remember the origin is the point 0, 0, right? So let's go ahead and plug this into the function and see what we have left. Okay, so we have the distance is equal to the square root of, this would be x1 minus 0 squared plus y1 minus 0 squared. Then we get the square root of x sub 1 squared plus y sub 1 squared. Okay, so again, we run into this problem where we still have y in our function. Okay, we want to get rid of that. So the way we're going to do that is by replacing it with this function here. Okay, so I'm going to say that d is equal to the square root of x squared, we'll leave the subscripts out, x squared plus x squared minus 1 squared. Okay. Let's go ahead and simplify this portion. Okay, I'm going to do this in some scratch work. So scratch. All right, so I've got x squared plus x squared minus 1 squared. Okay, remember we need to write this second part out. This is not going to be x to the fourth minus 1. It's actually x squared minus 1 times x squared minus 1. We're going to FOIL this. I'll leave the foiling to you. So we get x squared plus x to the fourth minus 2x squared plus 1. Okay, and the last thing we need to do is to combine like terms. We've got an x squared and a minus 2x squared, which will give us x to the fourth minus x squared plus 1. Okay, and so that becomes everything under the radical. Right, so we have that d is equal to the square root of x to the fourth power minus x squared plus 1. All right, and now we have all of the terms on the right-hand side in terms of x. So everything has an x on it. So we have our function. All right, so I can go ahead and write that the distance with respect to x is the square root of x to the fourth power minus x squared plus 1. So this is part A. Okay, the remainder of the parts are going to come pretty quickly. I do want to check to make sure that this is correct. So just kind of follow along. You don't have to write anything down here. All right, so check. Let's go ahead and assume that x is equal to, let's go ahead and assume that x is equal to 0. Okay, let's make it simple. Okay, if we were to plug this in and find the distance the long way, okay, so finding the distance the long way, we're going to plug it into this equation here. Okay, so remember we have 2 points. We have x is 0, and then we also are using the origin. Okay, so one thing that we do need to have here is our y value. So we need to solve for our y value. So it's going to be, the way we do that is going to be y equals x squared, so 0 squared minus 1, right? So we're using this equation from the beginning, okay? And we get -1, so our y value here is -1. Then we're going to plug it into the distance formula. So we're going to plug this and this into the distance formula. See what we get. We get the square root of x minus x. So x is 0 minus 0 squared plus -1 minus 0 squared. So we get the distance is equal to the square root of 0 plus, this would be -1 squared. So we have +1, and we get a distance of 1. Okay, so using the long method, this is what you would have. Now let's check using our function. So remember, our function is this here. All right, so we have the distance of 0 is equal to the square root of 0 squared plus, 0 to the fourth power minus 0 squared plus 1. Okay, so we have the square root of 0 minus 0 plus 1, which is the square root of 1, which we get 1. So our function did work out here. Okay, so notice that we were able to plug it into the distance formula here, and we were able to find it using our function. So this is our mathematical model. Right, so now, if you want to use your calculator, and I'll show you guys, you can refer back to some of the notes that I have up on Canvas, but you can type this into the calculator and then simply plug in these x values for parts B through D and see what you get. Okay, but I'm going to do this by hand. All right, so we've already figured out that if x is equal to 0, that d of 0 is equal to, we've said 1. Okay, so we've already done the work for this one. All right, part C is asking for d of 1. Okay, so since our model works, we can use this. We've got d of 1 is equal to the square root of 1 to the fourth power minus 1 to the second power plus 1. So we have, this would be, let's see, this would be 1 minus 1 plus 1, and we get the square root of 1, or simply 1. All right. Okay, now Part D is saying what is the distance if x is equal to the square root of 2 over 2. Okay, so the distance of the square root of 2 over 2 is equal to the square root of, this would be the square root of 2 over 2 to the 4th power minus the square root of 2 over 2 to the 2nd power plus 1. Okay, so the inside here is probably what's going to take the most work if you're not doing it by with your calculator. So let's see, the square root of 2 over 2 to the 4th power is equal to, well, I'm going to simply raise each of those to the 4th power. So 2, we'll do the bottom first. So 2 to the 4th power is 16. The square root of 2 to the 4th power would be 2 times 2 or 4. So we get 1 over 4. All right, then we're going to look at the square root of 2 over 2 squared. That would give us 2 over 4, so that would be 1/2. Okay, and then we have plus 1. So let's go ahead and replace these. We've got the square root of 1/4 minus 1/2 plus 1. Okay, so this gives us let's see, 1/4 minus 1/2 would be the square root of negative 1/4 plus 1. This would give us the square root of, let's see, that would be 3/4. And we can simplify this to the square root of 3 over 2. Okay? I do want this to be in rational form. I don't want this to be a decimal. Okay, so make sure that you're doing this in rational form. All right, so the distance where x is the square root of 2 over 2 is this. All right, part E we will actually do in a separate video where we're calculating using the calculator. Okay, so I'll post a separate video on separate video. Okay. All right. So a rectangle has one corner in quadrant 1 on the graph of y equals 25 minus x squared. Okay, and this I actually do already have graphed right here. Okay, so it's graphed right here for you. Another at the origin, a third on the positive y-axis, and a fourth on the positive x-axis. Okay, so what this rectangle is going to look like, and I would always suggest going ahead and kind of drawing these out. Okay, so we have 1 point on the graph in quadrant 1. So remember that this is quadrant 1, 2, 3, and 4. This is what they're referring to. Okay, so there's 1 point on the graph. Okay, so we have maybe a point right here. Okay, it doesn't really matter, so we'll call this xy. Then there's another point on the origin, so on the origin here, so this would be the point 0, 0. A third point on the positive y-axis. Remember that this is a rectangle, so this is going to be directly above and to the right, to the left of our points here. Okay, and then the last point is on the positive x-axis, so right down here. So we have this rectangle, and they're asking for us to express the rectangle in terms of, express the area of a rectangle as a function of x. So we should have the area in terms of x. So what I'm looking for here in part A is A with respect to x. So in other words, all of the variables on the right-hand side should be in x. Okay, so the way we're going to do this is by first remembering that the area of a rectangle is the length times the width. Okay, now we want these to be in terms of x. Okay, so I'm going to go ahead and assign one of these letters, so either length or width, as an x. So I'm going to say we're going to define the length. Actually, let's go ahead and use the width, which is usually the right and left. So we'll go ahead and say the width is x, and we'll say that the length is equal to y, okay? Now we know what y is, right? So y is actually this thing here, okay? So I can actually go ahead and say that the y is 25 minus x squared, okay? So anytime we have this equal sign, remember that these mean that these are interchangeable. I could change the length with the y, or the y with the 25 minus x squared, or the length with the 25 minus x squared, okay? So we're just assigning values. All right, so let's go ahead and start plugging things in. Okay, so to start off with, we have that the area is equal to the length times the width. We said that the length is actually y, and the width is actually x. Okay, notice that we still don't have in terms of x yet. Okay, so what we're going to need to do is we're going to need to change any of those values that are not in terms of x back into terms of x. So I have y over here, I have y is actually equal to 25 minus x squared. Okay, so I'm going to replace my y with 25 minus x squared. And then we still have times x at the end, so times x. Okay, then I'm simply going to simplify. So we've got 25 times x minus x to the third power. All right, so we actually came up with this function. So we have that the area with respect to x is 25x minus x to the third power. Okay. Now it's going to ask, what is the domain of x? Okay, so the domain of x is going to be, we can actually use the graph over here to kind of determine. Now, if we're just looking at this function here, right, so we're just looking at 25x minus x cubed, the domain of this function is going to be from negative infinity all the way up to positive infinity. So if you actually graph this, that's what it is. Okay. However, in our terms, our picture is going to be from 0 to 5. Okay, so we're only looking for the area that our actual rectangle can take. Okay, so the area, the x's that we can actually pick here are going to be from x equals 0 all the way up to x equals 5. Okay, so this is our domain. Now, what you need to pay attention to is if x is equal to 0, do we have an area? And the answer would be no. So x does have to be greater than 0, and x does have to be, I guess we can go ahead and include it. So we'll go ahead and include 0, we'll include 5. Okay, so if they are 0 or they are 5, that just means that we have an area that is 0. Okay, so that's what we're looking at. All right, and so again, parts C and D I will post in a separate video using the graphing calculator function.